Hello sir, I'm our Vivian Maria from the evening class software engineering. I'm here to present the data communication coursework, and I'll start by talking about the different categories of multiplexing that were asked in question number 1. I'll start with the frequency division multiplexing. Well, this is a technique that allows simultaneous transmission of multiple signals across a single data link by sharing portions of the link for transmission. Here we know that we can have our input lines carrying signals that are multiplexed into a composite signal that will be transmitted over the single data link, and the signals in that composite signal will be able to take portions of the link known as channels, because a channel is a portion of a link. And we can say that signal 1 can take over channel 1, and signal 2 can take over channel 2, and signal 3 and take over channel 3, and so on and so on, and then they are demultiplexed and then put on the output lines. In the wavelength division multiplexing, we talk about the combination of the different signals at different frequencies that we are going to transmit over our optical fiber channels. Here we can see that we have our input lines carrying different signals of different frequencies that are multiplexed and then transmitted over our optical fiber channels, because we know that in wavelength division multiplexing it involves optical fibers transmitted through the optical fiber channels, and then they are demultiplexed into the respective different signals with their different frequencies. Well, in wavelength division multiplexing, we exploit the large bandwidth of optical fibers to meet the high growth of bandwidth demand in the internet, because we know optical fibers have a high data rate that compared to the metallic transmission cables. In the synchronous time division multiplexing, we talk about the assignment of fixed time slots to each input line, whether it has data to send or not. Like we can look at my diagram here. I have input lines from A to E, but input line has only one data unit to send. Line C has nothing to send, and line E has one data unit to send also, but line B and line D have two data units to send. On multiplexing, when you look at the frames we have here, we can see that the first frame has fixed time slot for data unit E2, data unit D2, and data unit B2, but it also assigned fixed time slot to line A and line C that didn't have data to send, implying here we assign fixed time slot to every input line whether it has data to send or not. Then in the interleaving, we are going to talk about the two very fast rotating switches that it is composed of, and these switches rotate in opposite direction, in that if one switch is rotating in an anti-clockwise direction, the other one will be rotating in a clockwise direction. And if on multiplexing, if a switch opens in front of a connection, the connection will be able to send a unit onto the path. And on demultiplexing, once a switch opens onto a connection, the connection will be able to receive a unit from the path. And interleaving is also a form of error correction, in that it aids synchronization, such that if signals are sent from the receiver, if signals are sent from the sender, they should be received intact at the receiver side. This helps us to correct the errors, because the data will not be altered. In the frequency hopping spread spectrum, we talk about the transmitting of signals by rapidly changing the carrier frequencies among distinct frequencies occupying a large spectral band. And frequency hopping spread spectrum is mainly applied in the transmitting of radio signals, because at one moment a signal modulates one carrier frequency, and at the next moment a signal modulates another carrier frequencies. On number 2, when we talk about how multi-carrier modulation scheme works, because it is also known as the orthogonal frequency division Multiplexing. Well, multi-carrier modulation scheme is a principle of transmitting data by driving the streams into several bit streams, each of which has a much lower bit rate, and by using this substream we can be able to modulate the several carriers, and this scheme works in a way that when a signal is modulated by the sender, its sidebands spread either side, and a receiver can successfully demodulate the data only if the receiver receives the whole signal, and there should be accurate synchronization between the sender and the receiver. Then this scheme also has the ability to cope up with several conditions like attenuation, interference, and frequency selective fading due to multipath. Then in the intersymbol interference, well, intersymbol interference is the distortion of signals in which one or more symbols interfere with subsequent signals, causing noise or delivering a poor output. And when you talk about how it arises, well, it arises due to the multipath propagation, in which a wireless signal from a transmitter reaches the receiver via multiple paths. And when this signal reaches the receiver via multiple paths, it implies that those signals can have different lengths, and that will result into receiving them at different times. And these interferences can include reflection, refraction, and atmospheric effects. On the uniform and non-uniform quantization, well, uniform quantization is where the quantization levels are uniformly spaced, and for the non-uniform quantization is where the spacing between the levels will be unequal. And when we talk about the signal to noise ratio in the non-uniform quantization, we can see that it is maintained constant for a wide range of input power levels, but for the uniform quantization, the signal to noise ratio decreases in input power levels. Then non-uniform quantization is also known to be robust and reduces quantization error, and the uniform quantization has some amount of errors. Then uniform quantization is categorized into the mid-thread and the mid-rise quantization, while the non-uniform quantization is not categorized further. When I talk about the categories of the uniform quantization, in the mid-thread quantizer, the origin of the signal lies in the middle of the thread of the staircase, and in the mid-rise quantizer, the origin of the signal lies in the middle of the rise of the staircase. On the categories of satellites, I'm going to talk about the three categories of satellites, which are the geostationary Earth orbit satellites, and the middle Earth orbit satellites, and the lower Earth orbit satellites. In the geostationary Earth orbit satellites, we know that the sending and the receiving antennas must be located onto each other's location all the time, because if a satellite is faster or slower than the Earth, then the satellite will be only useful for a short period of time. So to solve this, the satellite must be moving at the same speed as the Earth, or so that it may seem to be in a fixed slot. Then we are also required to have like three geostationary satellites located at an equal distance far away from each other, in order to provide a full global transmission. Then the geostationary Earth orbit satellites are also associated with the equatorial orbits, and they have a period of 24 hours to make a complete rotation around the Earth. Then the middle Earth orbit satellites are mostly known for navigation, and they include the global position systems known as the GPS, that is owned by the United States government, and it's mostly a satellite based on navigation systems, and it takes a period of 6 to 8 hours to circle the Earth. and it is located in between the two Van Allen belts. Plus, the middle Earth orbit satellites are associated with the inclined orbits. Then the lower Earth orbit satellites are known to be a bit closer to the Earth more than the geostationary Earth orbit satellites and the middle Earth orbit satellites, but they have examples including the Iridium systems that provide a wide range of communication using handheld terminals, because we know the lower Earth orbit satellites have a cellular type of access similar to cellular telephone systems, and they also include of the Globostar that requires satellites and the Earth stations, and the Globostar satellites are also similar to the Iridium systems. Then we have the Teledesic satellites that provide a broadband internet access for users all over the world, because they provide a fiber optic like communication, because fiber optic have a high data rate. Then the lower Earth orbit satellites, their round trip around the Earth is normally less than 20 meters per second, which is acceptable for audio communication. As we can see from the diagram I have here, I can show you the location of my three categories of satellites, because we can see that the geostationary Earth orbit satellites have a higher altitude compared to the middle Earth orbit satellites, and compared to the lower Earth orbit satellite that has the least altitude. And we can see the middle Earth orbit satellites located in between the two Van Allen belts.